So before diving into the presentation, a small background about me. So I was born and grew up in Colombo, Sri Lanka, and I did my undergraduate studies there, and then moved to Canada, to beautiful Vancouver, to do my graduate studies. I did my master's in Vancouver at University of British Columbia, and then moved to Montreal to do my PhD at McGill University, and then currently I'm living and working in Kingston, Canada. Along the way, I worked in different software companies, some small, some large, gathering experience. Currently, I'm working as a researcher at the Center of Software Excellence at Huawei, Canada, working on software engineering research. So my past research has been analyzing software engineering data, mainly software repositories, to understand the software development process, and build tools such as refactoring tools to improve the processes and improve the productivity of software developers. Right now, we are looking into how to use generative AI to build software applications and build foundational model-based applications themselves. So I'm interested in studying about how to build agentic systems, how to evaluate them. So that's my background. So let me begin by defining this term, vibe coding. How many of you have heard about this term, vibe coding? Yeah, so almost all of you. But the interesting thing is, this term was introduced in February this year by this prominent researcher, Andre Karpathy, in one of his tweets. He explained this workflow he was doing. He was not looking at the code, but just giving a prompt to a foundational model, and even without checking the code, he was accepting what the model was generating and having some benefit from it, having fun with it. And he explained this concept and coined this term called vibe coding, vibing with the foundational model. That was February this year. And then soon after, there's even books published by prominent publishers about vibe coding. Some are talking about doing vibe coding in production and saying it's the future of programming. But we have to focus on few terms that Andre used in his tweet. He said he's forgetting the code, that the code even exists. And he was saying, it's not too bad for throwaway weekend projects, but now we are talking about building production systems using vibe coding. And then he say, oh, but it's not really coding. So that's the situation about vibe coding in the wild. At the same time, a lot of people are using this vibe coding or any other processes with foundational models to generate code. People are doing it in a lot of companies. So this is a recent talk about from a Stanford University professor about a study that they did. They studied how people use these generative AI technologies in their software engineering process. It was a long-term study, and it was a diverse study that has like 2,500 software engineering professionals over time. What they observed was, initially, yeah, the productivity increase was very high. They had like a 30%, 40% increase in generating code. But what they observed was, afterwards, after some time, it required a lot of rework. The solution the generative AI was proposing was either not good, or it introduced bugs, so it had to be reworked. So the original value, original productivity value it was reporting, we cannot trust them. We had to do a lot of maintenance work to get to the real thing that we needed, to reach the end goal. So the net productivity gain was reduced because of the maintenance it required. So it's a very interesting study. You can read the technical report about this. It has a lot of other interesting observations as well. So this brings us to this interesting phenomenon now. So vibe coding is this whole idea of just prompting a model, asking it to generate code, and using the generated software. But if you think about production systems, we need to create code that works, and we have to verify that it works, and we have to understood the code has to be understood by humans and other machines. And we should support maintenance, adding new features to this software. So we need to consider performance, accessibility, security, maintainability, cost efficiency, all these different things. So the system that we need to build is, instead of some black box that we are asking a model to do things, we need to think about agents doing requirements engineering, agents doing design, code generation, all these different things. And basically, we are trying to reimagine the software development lifecycle with foundational model-based agents, because we need to think about all these things. But are we building systems like this? That's the problem. Turns out we are getting there. So this is one of the blog posts. I don't want you to read this small text, but I just want to give you the big picture. So this is one of the blog posts from an experienced software engineer, how they are using foundational models, called Jeffrey Huntley. So it seems what we are trying to get into is a reimagining or rethinking of the software development lifecycle. How he's using foundational models is, first, he has a requirements phase where he's chatting with the foundational model, clarifying the requirements, planning things what he needs from this software, build a very detailed requirements document, then build a very detailed plan, and then use that requirements and plans to do the actual implementation. So the implementation is also an iterative process, very similar to the classical software engineering process, to get something out of these foundational models. So it seems we are trying to reimagine or reinvent the wheel of software development lifecycle, use these foundational models. So this is coming from the industry. And it's not only limited to these blog posts. So Amazon recently released this AI agent or AI development tool called Amazon Kiro. The fundamental concept there is spec-driven development. So before generating the code or before generating the application, it's chatting with the developer to come up with a very detailed specification or a detailed requirements document. They use a format that is been devised by some companies some time back, called the year format, to come up with this specification and then use this specification to build the actual software. So it seems we are relearning or borrowing the concept from traditional software engineering to make robust software using foundational models. And then there's all these startups talking about intent when we are developing software. So there's this company called SpecStory. They are calling intent is the new source code. And even there's startup founders talking the most important thing in this area right now is understanding the user intent and how to do that. So even in visual models, they're talking about intent-driven visual creation. So there are some concepts from software engineering that we have learned in the past that we have to revisit, or we have to focus on the definition. So there's the concept of goals. That's like a high-level, broad objective that we need from the software project, what we need to achieve. It defines the desired future. So it's basically trying to answer the question, why are we building this software? So, and then requirements are more detailed statements describing what the software system's functionality is. So it's more like qualities it must process. It could be functional or non-functional as well. So there could be details like the system shall accept Visa and MasterCard, things like that. Interesting thing is goals, requirements are usually documented. But then there's the undocumented thing that is intent, the underlying purpose or reason or rationale behind these goals and requirements. The interesting thing is these intents are not always documented, it's not directly expressed, so we have to identify from whatever the user is saying or whatever the user is asking the model to do. We have to extract the intent to do a better job of generating foundational model-based applications or generating software. So we've been thinking about how to design interfaces or design systems that we can do this intent extraction and the requirements elicitation. So this is one of the initial prototypes that we came up with. It had this piece of conversational interface. I think Ahmed showed a quick demo of this. We had this allows the user and agent to have a conversation and express their, align their requirements. And then we have a generated set of elicited or refined requirements and refined workflow where what is the actual functionality that we want to get implemented. So there's this idea of the interface, but now how can we actually elicit the intent, extract the intent? What is the backend we should use for this? So there are concepts in the cognitive science that we can get help here. One thing is the theory of mind. So theory of mind is when we are having a conversation between two people, when person A is talking, person B is trying to infer what is the other person is thinking. So that is, we are trying to build a model of the other person's mind. So this is the study in cognitive science. It's called theory of mind. So how can we, so people are looking into how to apply this concept into AI-human interactions as well. And they are talking about mutual theory of mind because the agent has to infer what the user is thinking, and at the same time, user needs to think about, oh, what was the agent's intent when it generated this code or when it generated this response? So that's the mutual theory of mind we have to focus about. And people have already looked into applying these concepts. One such concept is perspective taking. We want to get into the other person's shoes and imagine their situation to come up with a better response. People have looked into how to apply this to LLMs. And then building beliefs, like understanding beliefs, what is the other person is thinking, what is the world model the other person is perceiving. So there are attempts into building systems like this. So we borrowed this concept of theory of mind to build a multi-agent system for requirements refinement. So in this system, you can see we have multiple foundational model-based agents. So there's initially there's an agent to analyze the user's request to check if it is about refining requirements or refining a workflow. If it is about refining requirements, we get the help of these theory of mind agents that's trying to infer the user's expertise, user's sentiment, and also the subtopics that we need to dig deeper into, get a deeper understanding of the user's requirements. So we get the help of this theory of mind helpers to refine the requirements and come up with the detailed requirements and detailed workflow. So this is the architecture of this multi-agent system. And we powered our requirements refinement interface or the next generation IDE using this backend. So here you can see while the conversation is going, we try to infer the user sentiment, expertise level, and the domains that the user is interested in, and use these extracted details to modify the responses of the system and to refine the requirements. So you can see in this prototype, we are displaying the extracted sentiments and the extracted expertise. So it's all good. We can build a system like this, but we have the problem of how to evaluate such a complex system. It is not just about a small task. We have, there are a lot of aspects we have to worry about. So we built a whole machinery to do the proper evaluation also. So first thing, we had to consider different diverse scenarios. So we made sure we generated different domains and different scenarios that can lead to different intents. And then we simulated human AI interactions without our system and with our system. Without our system, it's just prompting a foundational model, just a foundational model with a system prompt explaining the requirements refinement, and also with our multi-agent system. So we generated such, from these generated intents, we simulated the conversations, and the output of the system was different dialogues, workflows, and requirements generated with our solution and without our solution. But these generated artifacts, we have to evaluate for different criteria. So we looked into three broad things: output quality, the grounding, the consistency of the generated requirements versus the conversation we had with the system, and the cost of this system. Like, our system could be very good, but if it is very costly, it is not plausible to use it in a production system. So first, we looked into the clarification aspect of the system. So, in practice, people have identified clarification is required due to several reasons. First is because of ambiguity. Something user said can be interpreted in multiple ways, or it is inconsistent. So there are some conflicts between the things the user said, or it could be incomplete. So whatever user said, the requirements are not sufficient to generate code or generate the application. So due to these three reasons, we may need to refine and have a longer conversations with the user. So in state of the art, if you are just working with a foundational model, people have identified, even in 60% of the cases, majority of the cases, foundation models are directly jumping into solutions. It's not asking enough questions from the user to clarify these things. But with the system that we built, we achieved longer conversations. The system can have a longer conversation to clarify these things, to resolve the ambiguities, resolve the inconsistencies, and make the requirements complete. So our system had longer conversations, significantly longer conversations with the baseline compared to the baseline system. But then we have to study the usefulness or the output quality of this requirement refinement system also. So as I explained earlier, we had different diverse personas covering diverse scenarios. And then even with these artifacts, it's not very straightforward how to define the output quality. What constitutes as a good set of requirements, good set of good workflow. So we use a panel of foundational model judges to analyze a sample of scenarios and analyze a sample of requirements documents and come up with their own rubrics to judge this. So we have identified 5 core rubrics like that, such as assistance is able to accurately identify the user's intent, requirements capture all users' intent, likewise. So then we give these extracted rubrics to another panel of judges to evaluate the generated requirements. So what we found out was, based on this panel of judges assessment, the system that we built scored significantly better compared to the baseline across these metrics. And then we wanted to check how detailed the requirements also. So we defined the metric called requirement richness, where we measured the existence of content words there also we found out our approach generated more detailed requirements. But it could be all good. The output quality, the requirements could be detailed. It could be of very high quality, but we know foundational model systems always suffer from this problem of hallucination. So they could be hallucinating requirements that users didn't ask for. So we wanted to check for the consistency also, whether the users generated refined requirements are grounded in the actual conversation. So here we borrowed a concept from natural language processing called consistency in abstractive summarization. So we consider the generated refined requirements as summaries and the original conversations as the source documents, and we check how consistent these two are. And we found out our system does not lose any consistency. It also has good consistency with the source document. Then, of course, we analyze the cost also. Because of all this multi-agent system and going back and forth with the user, we found out our system makes a lot of API calls and also consumes a lot of tokens to do this requirements refinement. So that is the cost involved in this requirements refinement process. So with these lessons learned, we have built an updated versions of this requirements refinement system. So here you can see on the left-hand side, we have this two-way communication with the agent and the user, and now we also support this multimodal way of expressing things. Users can upload images, and also the model can output things in different modalities as well, because we identified that is another improvement that is required. And then on the right side, you can see along the way, we track the progress of the requirements refinement. We identify the topics that we want to cover in the beginning, and if you look at the top right corner, you can see we report on the progress. Whether we have sufficiently clarified this subtopic, sub-area, or we need more questions to ask. So on the top right corner, you see this progress tracking, and on the top, bottom right corner, you can see the extracted requirements summarized, displayed, because we realize users may want to see what is the extracted requirements and may want to edit and modify them. So that is another improvement. So, and the goal is to make it end-to-end. So requirements refinement is only part of the process. Then we want to build the application based on these requirements, and we want to make it also more robust and efficient. So that's also the work that we are working on right now. But this comes with a lot of pitfalls, challenges, and opportunities. One is this idea of psychophancy. If you haven't heard the term, this is like people have identified more recently, foundational models tend to agree with the user more. So even when they should be criticizing the user or identifying mistakes, it always try to be too flattery. So they have used the term psychophancy to label this phenomenon, and even like top foundation model providers have made changes to their system to be less psychophantic, because users found this very annoying. So we have to be very careful when we are talking about concepts like theory of mind, whether we are agreeing too much to the user, or we are having a conversation to align both parties to eventually generate something useful. And then there's this concept of reasoning models also recently. So of course there's a question about whether these reasoning models are actually reasoning or not, but how can we use the reasoning traces or reasoning trajectories of these models to help with the requirements refinement process. That's another interesting area we should focus on. Because there are positive aspects of reasoning models, but also reasoning token generation is costly, so you have to, and they tend to sometimes overthink as well, so we have to be very careful about this trade-off between the use of non-reasoning versus reasoning paradigms. And then, as I briefly mentioned earlier, chat is not the only way of interacting with these systems. People have looked into generating mini applications and presenting them to the user and asking them to asking for feedback and letting the users interact with these mini applications. So we have to think about how to move beyond the chat interfaces, all these tweakable interfaces. And then the models are multimodal now, so we can express requirements in non-textual forms as well. It could be a whiteboard diagram or some diagram drawn in a napkin. So you can just give it to the model and ask it to use for the requirements refinement process. And some people have even talked about coding while walking the dog because these models support audio input. So it's another form of providing input to the model. So how can we use these multi-modal capabilities in our applications? So to summarize, we have to think about new interfaces for this requirements refinement process. But we had to use concepts like theory of mind and multi-agent systems to support the backends for this requirements refinement process. And then we had to design detailed evaluation processes to evaluate such a system because there are their own challenges like multi-round conversations and a lot of aspects to watch out for. But the good news is we saw very good results compared to the baselines with this approach. So that's the summary of my talk. Thank you very much. You can ask if you have any questions.
Thank you. Questions?
Hi, thank you for your lecture. Regarding what you said about collecting requirements, specific requirements, quality requirements, this is my experience as well with so-called vibe coding, that's the key to it. But I also find it extremely exhausting to read the very, very large amounts of text that are being generated as we work. And I'm wondering if as you're thinking about IDs for developers that take this spec-driven development into account, how you think about the motivation aspect or making development still be something that's fun and enjoyable and not bureaucratical or heavy.
Yeah, so that's a very interesting question. That's a question that we've been thinking a lot also. So we had to find this balance about being detailed or being complete with the requirements because it's really needed to make a robust system. At the same time, we shouldn't be exhausting the user or the developer. So we have to find this balance. So we've been experimenting, or we've been like building things to tackle this also. So one idea is we check the sentiment of the user, like when the conversation is going, if the user is saying things like giving short answers. So if we feel like the user is exhausted, quickly wrap up the requirements refinement process and try to generate something and then get the feedback that way. Because in the requirements engineering literature, there are works that says, okay, users may have trouble expressing their requirements, but when something is generated, they can say if it is good or not. So on one end of the spectrum, we can quickly go to generate something or generate multiple solutions and give it to the user without exhausting them with the choices or the questions a lot. And asking them to select from one of the few choices that was generated, or ask for them for detailed feedback. That's one aspect. But then for some of these things, for compliance reasons, also for some other reasons, we have to make sure that we ask these questions from the user also. So we have to make sure we have that balance. Like, we cannot skip the questions and assume things that user didn't express. So it's a very, very tricky thing, and it depends on the application and also the domain also. But there are a lot of research, like in the HCI domain, about this, how to find this balance. But there's no a generic solution. It depends on what you need to build and what are your legal compliance and all these other requirements.